Hello, grade 7. How are you? Hope you all are safe and well. Previously, we studied about seasons. We studied about the night sky. And we said that in seasons, we have 4 seasons per year because the Earth axis is tilted. So each 6 months will tilt away from the sun, and then the rest 6 months will be tilted close to the sun or towards the sun. So also, and this tilting is explaining why the summer is warmer than winter, and why the days are longer, and why the sun is higher in the sky in summer more than other than winter. Today we will study about stars. So we said that we have stars in the night sky. We can see stars, and the biggest star in our solar system is the sun. So please grab your highlighter and follow me. Page 58. Stars. Our sun. Our sun is a star. You might think that our sun is the biggest star of all, but it's not actually quite small. Some of the bigger stars, such as Arcturus, are hundreds of times bigger than our sun. Arcturus looks much smaller because it's so much further away. So here is our sun in this picture, and here this Arcturus. So we can see it small because it's so much further away from us. It's not like our solar system. In our solar system, we can see only the sun is big, but this one is out of our solar system, so we can see it small. The stars are shining all the time, but we can only see them when the sun is low in the sky or at night. This is because the light from the sun is so bright we cannot see other stars. So during the midday or during the daytime, we cannot see the light from the stars unless the sun is low, like in sunset or at dawn, sun rising. We can see the stars twinkling in the sky, or at night. We can see them also at night. And we studied before about stars, and we said stars appears to twinkle because the light can change direction when it travels to the atmosphere. So this is the introduction about the stars. The Earth spins. During the night, the stars appear to move. If you look at the night sky for a few minutes, you cannot see them moving. If you take a photograph over several hours, the stars make tracks from the northern hemisphere, and looking north, the tracks form circles. So look at this picture. So here, if we took a photograph, we can see them like moving across the sky from the northern hemisphere and like going north or looking north. So if we just if we try to stare at the sky, we cannot see them moving, but if we took a picture, we can see them changing their positions. So this is not because they are moving. They are not moving, but we should not forget that the Earth spins around its axis anti-clockwise, so that's why we can see them moving exactly like the sun. We said before that we can see, or we can notice that the sun is moving across the sky during the daytime, but it's not moving, but we are moving. The Earth is moving. The Earth spins around its axis, so that's why we can see the sun is moving, and the night stars moving also. The stars are not really moving in circles. They appear to be because of the motion of the Earth. So we said the Earth spinning around its axis anti-clockwise, So this movement, it's like move in circular path. So in this case, if we took a photo, we can see them like this exactly. They are moving in this way. It's like having moving in circles. But this is because the Earth is spinning. So not the motion of the stars, just the motion of the Earth. It happens because the Earth is spinning on its axis. And this is a good question here. Why we can see the stars moving in circles? So they appear to be because the motion of the Earth. It happens because the Earth is spinning on its axis. If you take the photograph from the northern hemisphere, the stars closest to the center of the circles is the northern pole star, or Polaris. So here we have a star which is the closest to the center of the circle. Here we call it Polaris because this is closest to the north pole. It's called a pole star because it's directly overhead when you are standing at the North Pole. So if you are in the North Pole, you can find these stars above you, directly above you. And it's lined up with the axis of rotation of the Earth. So if the Earth is like this, spherical, and this is the axis, we can find the star which is Polaris here exactly, lined with the axis, in the same position above the axis, which is lined with the rotation of the axis of rotation of the Earth. You might get the same effect if you take a photograph in the southern hemisphere looking south. This time the star closest to the center of the center is southern pole star, which is called Sigma Octantis. So the northern pole or the North Pole star called Polaris, but the southern star or the southern pole star called Sigma Octantis, which is the closest one. All the other stars apart from the north and south pole stars appear to move during the night. Sailors have used the pole stars for navigation because they do not appear to move. So as I said earlier, if we looked at the stars, we cannot see them moving. That's why the sailors took this advantage and they were navigate using the stars, which is like finding their direction using the stars because they know that they do not move. Okay, now what about the constellation? Constellations? What are constellations mean? People have been trying to make sense of all the stars for thousands of years. A collection of stars that makes a pattern is called constellation. So when we see a group of stars or collection of stars across the sky that can make a pattern, like a shape or like an arrow or something like a hawk, or we can see it in a shape. This is a pattern. Okay, can make a special drawing we can see, okay? This is called constellation. Such as the Plough, which is Ursa Major. This is a name, this Plough or Ursa Major, this is a name of group of stars, which is this one. Look at this pattern. They look like, kind of like a hawk, so this is called Ursa Major. It's easier to describe stars in constellations rather than individual stars. So that's why they group them in constellations or collections to make it easy to describe them or to identify them, other than like star by star. if you live in the northern hemisphere, you will see different stars from someone who lives in the southern hemisphere. So we said here earlier in this part that we have stars on above the northern hemisphere lined up with the axis of the Earth. And also we said we have another stars that lined up with the southern hemisphere. So if someone is living in the northern hemisphere, he will not see the same stars as someone lives in the southern hemisphere. Cassiopeia is a constellation that you can see from the northern hemisphere, while you can see Crux from the southern hemisphere. Here we have a good question as complete questions, or fill the gaps. So we can say that which collection of what's the name of the constellation that we can see from the northern hemisphere, or fill the gaps. For example, constellation that we can see from the southern hemisphere is called what? That means called Crux. So we saw now the effect of the spinning of the Earth on the stars. What about if the Earth when the Earth orbits the Sun? You see different stars in the night sky in December from those in June. The half of the Earth that is dark is facing the opposite way in the sky in June and December. This is because the Earth is in orbit around the Sun. So here is the Sun, and when the Earth is moving in this direction like this, because we said anti-clockwise, so each time the stars are changing, we can see different, not changing, we are changing our position, but we can see different stars. So if you can try even this, to do this, if you stare at the sky at night, at least once a month, you can see different stars in June and December, because each time the spinning, the orbiting, when the Earth is orbiting the Sun, it's changing its position. So in this case, we can see different stars or different constellations. You can only see the stars in the direction facing away from the Sun. The constellations that you saw 6 months ago are blocked by the Sun. So if we are facing the Sun, we cannot see these constellations that we are seeing when we are in the dark. So that's why we can see different constellations. So we can see them only if they are facing away from the Sun. The life and the death of the stars, of a star. So we all know the life cycle of an animals, of plants, of humans, of all these creatures on the universe, in the universe. So what about the star? Does it have a life cycle also? Is it like life and it's going to die, or what? So let's see. Our sun has a life cycle as an animal does. It's born and it will die. Like all stars, the sun was born from a cloud of gas and dust called a nebula. So I needed to focus on these names, because if I asked you a question about the names, you have to memorize them. So nebula is the name of the cloud of gas. We studied about the stars before, and we said stars is an object that made of gas and dust. So first, it was born from a cloud with dust and gas together, which is cloud, like the particles are away from each other. Then the gravity pulled them together, okay, and formed this sun. So here gravity pulled the gas together to be like this. Hydrogen gas is used in nuclear fusion reactions to produce the energy that makes the sun shine. We studied about this nuclear fusion before, and we said that it's this nuclear fusion when the hydrogen atoms combine together to form helium and release energy, which is to keep the sun shining all the time. So here, after pulling these gas together, this hydrogen gas will be used in nuclear fusion, like combining these hydrogen atoms to form helium and to produce this nuclear energy, which is make the sun shine. This is the stage where our sun is now. We can see the sun is shining, so this is the stage, the current stage that we are in now, which is called the main sequence star. So what is the main sequence star? It's the stage that our sun is now, which is hydrogen gas used in nuclear fusion to produce the energy to make the sun shine. It will carry on shining like this for another 5 billion years. Eventually, all of the hydrogen gas will be used up and it will go through the final stage of its life. So in our lives, all the creatures on this universe, they have life cycle. They are first they are born, and then they are passing through stages: the childhood, the teenager, the adult stage, then when they become old people, and then they will die. So even the sun, first it was born from the cloud made of gas and dust. Then the gravity pulled these gas together. Hydrogen gas combined together to make a nuclear fusion reaction to make the sun shine, which is called the main sequence. And this will carry on after like another billions of years. Then the hydrogen gas, all the hydrogen gas will used up, and the final stage to make the sun die. If it will become a red giant and will swallow up Mercury, Venus, and possibly Earth as well. It will become far too hot for humans to survive on Earth. So at this point, the outer layers of the sun will be thrown out into space to form clouds of gas. After that, it will shrink back and become a hot white dwarf, and then cool down to become an invisible black dwarf star. So you can take a look over this picture here we have. This is the birth of the sun, and this it will continue. We are here now, and then it will continue shining more years, like billions of years, and it will warm up more and more in these years because of the nuclear fusion energy. And then it will be so hot, it will become a red giant. Now it starts to become a red giant. This stage where the hydrogen gas is used up, it will turn into red giant and swallow the Mercury, Venus, and maybe Earth, they said, the scientists said, even like Earth, possibly. Then, in this stage, these layers here, these outer layers, will be thrown away or out of the sun. It will become smaller, and it will become a hot white dwarf. It means small sun, okay, small sun, white sun. And then it will cool down to become a black invisible black dwarf star. A star that is much bigger than our sun is called massive star. It will turn into red supergiant, explode to form a supernova, and then form a neutron star or a black hole. So scientists, when they studied the sun, they said in future, in like very far future, there is another star called massive star, which is very big, bigger than the sun. And this massive star will turn into red supergiant. That means bigger than this red giant, supergiant. And then this supergiant will explode to form another object or another a star called supernova, and then it will form a neutron star or it will form a black hole. We all heard about the black hole in the space, and we all know that this black hole can swallow stars, planets, and no one can get there because no one can know what's behind it or what's inside it. So scientists estimated that this massive will turn into black hole and swallow the sun, and this is their estimating. So this is about the life cycle of the star. I hope you understood the lesson, and now let's go to the summary of the lesson. Stars. The Earth spins on its axis, so the stars appear to move during the night. The Earth orbits the Sun, so we see different stars in the summer and winter. So, as I told you before, this can be a good question. Why we can see different stars in the summer and the winter? Because the Earth orbits the Sun. Why and what about seeing the stars moving? Because the Earth spins on its axis. You can see different constellations in the northern and southern hemisphere. Sun's life cycle. First, Sun was born from a cloud of gas and dust called nebula. Then, nuclear fusion reaction to produce energy, which is the main sequence, we call it the main sequence. Then, the final stage of its life, it will become a red giant. Then it will shrink back to become a hot white dwarf, and then cool down to become an invisible black dwarf star. This was all about stars. If you have any question, please write it down, and don't forget the homework. And I hope to see you soon, safe and well. Bye-bye.